Hey there, Ellison here again. V equal to IR is one of the most popular electronic equations you can get anywhere. It was discovered by Simon Ohms many years actually ago. This equation, which was named after Simon Ohms as the Ohm's law, talks about how I is directly proportional to V. That is, how I increases as V increases or decreases as V decreases. So a constant of proportionality R is used to complete this equation, making it I equal to V over R, or as many of us know it, V equal to IR. So R represents resistance. What is resistance? Resistance is your opposition to current. So you can use this assumption of, say there are about 5 people moving in a street. A street is large. They have the opportunity to move freely the way they want. But when they get to a door and they all want to enter, they have to take turns. So this reduces the amount of people moving into an area at the same time in some form. So instead of 5 people moving at the same time, you have one person at a time. So that's a form of an example of a resistance. Every electronic component has a form of resistance in it, usually minute, but to introduce an amount of resistance that we need, we usually make use of the component called a resistor. So let's get down to what the resistor is. Like we've established, a resistor is a component used to provide resistance to a circuit. You can call it a passive element because it doesn't produce power, it just uses up power and resists. The symbol for a resistor is this. It was formerly done like this, but the new method of doing it is like this. There are many variations to resistors, like the variable resistor, and the LDR, that's light dependent resistor. It works on light. As light increases, the resistance decreases, and vice versa. And there's also the thermistor that changes with temperature, and there is the varistor that changes with voltage. So this is an example of a variable resistor. 3 knobs, a wiper, one end, the other end, and the wiper. So this turns the wiper to where the resistance should be. So it's drawn like this. This is the symbol for a variable resistor. There's also the LDR. You can see it. It has a place where the lights can fall on and change the resistance of the resistor, and it's drawn like this. With 2 symbols for lights falling on it. Sometimes you see a circle around it. Yeah. Then the thermistor symbol is like this. And the varistor, the symbol is like this. So this is a conventional resistor. It looks like this. And it just has 2 terminals. One in, one out. The colors you can see here are used to tell the value of this resistor. We'll discuss that in a bit. So by the left here, you can see a table that represents the color code for a variable resistor, for a fixed resistor that we have here. You can see that this table shows that black is 0, brown represents number 1, red 2, orange, and so on like that. If you look closely, you can see that the codes for the colors follows the rainbow ROYGBIV method, and without the indigo there, then there's gray, white, gold, silver, black. And there are different variations of coding. There is the 5-band like this one, and there is the 4-band like this one. 5-band and the 4-band. So let's try decoding this. From here we can see that there is red, red, brown, and gold. Red from our table represents 2. The second red represents 2. The next one is brown. So whenever you're decoding, the last one represents the tolerance. Tolerance means the plus or minus of values that this resistor might be, because during production there is no perfection in anything. Then the one next to the last one represents the multiplier. So for the last one, brown, we have times 10 raised to power 1 plus or minus the gold 5%. So we have 220 ohms plus or minus 5%. Now let's try for the second resistor. Here we have yellow, violet, black, orange, and brown. Yellow, violet, black, orange, and brown. So our yellow represents 4, our violet represents 7, our black represents 0, times 10 raised to power, orange represents 3, plus or minus brown. Our brown represents 1% tolerance. So we have 470,000 ohms plus or minus 1%. So 1000 can be written as kilo, so that's K. Symbol for ohms is this. So this is what we have. So these values, from what we can see, this tells us that this resistor has more resistance than the previous one. Knowing these values of resistors are important, and the types of resistors are important, because sometimes we need different resistors for different case scenarios. For instance, a voltage divider. A voltage divider is a combination of resistors used to break voltages into different values. For more information on that, check out the video on voltage divider.